Good day! Today we will be discussing about the rectilinear kinematics, continuous motion of a particle. But before that, let us first define what is a particle. A particle is anything that has mass but shape and size is neglected. So it could be a ball, it could be a small object like an apple, or it could be a large object like a car. So whatever it is, as long as the motion is characterized by the motion of its center of mass, that is a particle. So in this topic, we will neglect the effect of the size, the shape, and the mass of an object. We will focus more on the movement of the particle. In this topic, rectilinear kinematics, we will define particles in terms of its position, velocity, and acceleration. So position first is a particle is defined using position coordinate. We have here in the figure a particle P that is laid in a Cartesian plane. So particle P is on the right of a reference origin O. But in dynamics, we are expected to say that P has S distance to the right of reference origin O. It's because position is a vector quantity, meaning to say we have to represent position with magnitude and direction. In this case, P has S distance, that is the magnitude, and direction to the right of reference origin O. So that's how we say the position of an object. Again, position is a vector quantity, it has magnitude and direction. Now, if a particle is placed in a Cartesian plane, we can define its position by its Cartesian coordinate. In case P is on the left of O, the value of S, or distance of P, is negative. So it follows the sign convention of a Cartesian plane. If the particle's vertical position is above the origin or above the x-axis, its position is positive. And if the particle's vertical position is below the x-axis or below the origin, the position now is negative. Likewise, for the horizontal position of a particle, if it is on the right of the y-axis, the particle or the position of the particle has a positive sign. And if it is on the left of the y-axis, it has a negative sign. So for the units that we will be using for the position, for the metric, we use the usual meters, kilometer, centimeter. And if we are to use the US customary units, we have inch, foot, miles, and yard. And displacement is the change in position of a particle. So we have here in the figure particle P, it moved to the right. So we have delta S as the change in position of particle P. So that is the displacement. And delta S is equal to the final position of the particle, that is S prime, minus the initial position of the particle, that is S. Since particle P moved to the right, we have delta S is equals to S prime minus S. Displacement is also a vector quantity, meaning movement to the right is a positive and movement to the left is negative. And it also follows the sign convention for a vertical displacement that is similar to the sign convention we use for the position. Velocity now is the displacement of a particle over the interval of time. So, understanding displacement is vital in understanding velocity, because it deals with displacement and interval of time. Velocity, again, is displacement or delta S over the time interval delta t. Let's have here the figure that an object displaced from its initial position to its final position, and the change in position or the displacement is delta S. And velocity is a vector quantity, which means it should have a magnitude. The magnitude of velocity is speed, which is usually expressed in units of meters per second, kilometer per hour, or miles per hour. Velocity has magnitude and also direction. So direction of the velocity is indicated in the figure. So if the velocity is directed to the right, it governs the sign convention similar with the position. If the direction of velocity is to the right, it is positive, and vice versa, if it is directed to the left, that is negative. So it also follows the same sign convention with the position. So as an advice in solving kinematics, let us draw an arrow on the direction of a velocity of a particle when analyzing a problem. So let us go back to the definition of velocity, that is displacement or delta s over the interval or change in time delta t. And that is what we call the average velocity. There is what we call an instantaneous velocity, and we will appreciate the difference between average velocity and instantaneous velocity in this example. For this case, we have a car that's started to travel from city A to city B. City A is 80 kilometers away from city B. So let us define the difference between average velocity and instantaneous velocity. For example, the car started departing city A at 6 a.m. and reaches city B at 8 a.m. So the time travel is 2 hours. The average velocity now of the car is the displacement of car from city A to B over the time interval or time of travel from city A to city B. And that would be 80 kilometers for the time interval of 2 hours. The average velocity now of the car is 40 kilometers per hour. And that is the average velocity. Now, instantaneous velocity is a point velocity. The velocity of the car may actually be not constant throughout its travel point. For example, at point X, the car travels 70 kilometers per hour, and that is greater than the average velocity, that is 40 kilometers per hour. And at some point during the travel between city A to city B, for example, at point Y, there is a congested traffic. The car slows down at 30 kilometers per hour. So it is not constant throughout the travel. But instantaneous velocity tells you what is the actual velocity of an object at that particular point. It's because it measures the displacement at very, very small time interval. So when we say analyzing displacement at a differential time interval, we can say now that the instantaneous velocity is ds over dt. dt means a differential time interval. Let's talk about speed. Speed is a scalar quantity and is always positive. Let us refer to the figure that a particle P moves to the left and has a final position at P prime. But as you can see in the figure, P moves first to the right and then suddenly takes its turn going to left. Speed now is simply the total distance traveled over the elapsed time. And the total distance traveled by the particle is not delta s, but is rather st, which is the path of motion. And speed is the total distance traveled over elapsed time, and do not be confused with delta s over delta t with st over delta t. So again, speed is the total distance traveled, not the displacement. So at some point, delta s could be equals to the total time traveled, but in this case, the total distance traveled is not equals to delta t. So we represent the speed into v with the subscript sp, or you can have it as speed. So the total distance traveled st over delta t is again the speed, but velocity is defined as change in position over elapsed time. So do not be confused with velocity and speed. So displacement is simply the change in position, again, that if the displacement is negative, your velocity now is negative. It's because of the sign convention of the displacement. So let's have here a summary between average speed and average velocity. So average speed is st over delta t, always positive, and magnitude of distance traveled in time interval. Whereas average velocity is sign sensitive because of the delta s. Delta s, or the displacement, is also sign sensitive, and average velocity is change in position over interval of time. Let's have here a trivia. The Shanghai maglev train is a magnetic levitation train line that operates in Shanghai. The line is the third commercially operated maglev line in history, after the British Birmingham maglev and the German M-Bahn, the oldest commercial maglev still in operation, and the first commercial high-speed maglev with cruising speed of 431 kilometers per hour, or approximately 268 miles per hour. It is also the fastest commercial electric train in the world. Let's now go to acceleration. Acceleration is the change in velocity over an interval of time. So as you can see in the equation, the average acceleration is delta v, or the change in velocity, over delta t, that is the time interval. Let us refer to the figure. If an object initially having a velocity v and move to the right, and it has a velocity of v prime, therefore the velocity changes from v to v prime. The change in velocity now is v prime minus v, and that is your delta v. So we can have now the average acceleration equals to v prime minus v, or the change in velocity over delta time. If v prime is bigger, meaning to say, for example, if your v is 30 kilometers per hour and your v prime is 50 kilometers per hour, therefore we can say that v prime is bigger than v. Therefore, we can say that the object is accelerating, or we have a positive acceleration because it gains velocity. If it gains velocity, v prime is bigger than v. But what if v prime is smaller than v? So if v prime is smaller than v, we will have a negative value in the numerator of this equation. Therefore, the particle is decelerating. And even when the object is moving to the right, the arrow for acceleration is directed to the left. It's because the object keeps on moving to the right, but it is decreasing in speed, or decreasing in magnitude of its velocity. So the velocity here is still to the right, however, the acceleration is pointed to the left because it is decreasing the value of the velocity. Now, if v is equals to v prime and there's no change in velocity, therefore there is zero acceleration, or there is no change in velocity. So acceleration is usually expressed in units such as meters per second squared for metric and feet per second squared in English. And take note that it is also a vector quantity. It could also be categorized into two: average acceleration and instantaneous acceleration. And that's the same sense of difference between average velocity and instantaneous velocity. Let's take, for example, this one. Average acceleration is the change in velocity in the observed time interval. For example, at point A, the velocity of an object is 50 meters per second, and after 10 seconds, it traveled to point B, having a velocity now of 80 meters per second. So the change in velocity is 80 meters per second minus 50 meters per second. So meaning to say, the object accelerated from point A to point B at a time interval of 10 seconds. Now observe the units, you will come up with meters per second squared, and the average acceleration now is 3 meters per second squared. We are analyzing the acceleration of an object in a time interval that is not differential. So if we analyze the acceleration of an object in a differential time interval, we will have the instantaneous acceleration. For example, here, we have, again, the particle that travels from point A to point B in 10 seconds. Acceleration throughout the time of travel may not be constant at 3 meters per second squared, like the average acceleration. Therefore, instantaneous acceleration varies. It is different along the path of motion unless it is specified that it is constant. So, I'm sorry, this is not instantaneous, but this is rather this is not average, but is instantaneous. So, average acceleration is delta V over delta T, where delta T is time of observation that is not differential. And instantaneous acceleration is like a point velocity or point acceleration. That is, we analyze acceleration at differential time interval. So there we have position, velocity, and acceleration. Before we end this video, let me have you the story of the famous apple that fell on Newton's head, was initially at rest, and gains velocity as it reaches the ground. The acceleration is due to the Earth's gravity, which is approximately equal to 9.81 meters per second squared. The acceleration due to gravity is constant, meaning the change in velocity is also constant. Now, we have finally defined and understand position, velocity, and acceleration, and how are they related to each other. On the next video, we will learn to solve for the particle's position, velocity, and acceleration, and we will also derive the relationship of the three. So thank you very much for watching my video, and make sure you watch the next video for more learning.